Hello, Algebra 2, and welcome to 4-0, Factoring Polynomials. So we're going to go back a little bit and do a bit of review right before we start Unit 4, which largely has to do with rational expressions. One of the most important concepts in understanding rational expressions is understanding how factoring works. So, first thing we're going to do is learn how to find the GCF of an expression. Now, GCF stands for greatest common factor, and essentially we're taking out as much out of each of these terms as possible. And the easiest way to do that is to know exactly what each term is showing us. So here we have 8x squared y, and what we can break this down into, 8 is actually just simply 2 times 2 times 2, and then x squared is just x times x, and then times y. So this is the exact same thing as this expression right here. Right? It's broken down into all of these pieces. Now for 12, right, 12 is going to be 6 and 2, so we have a 2, and then 6 is just 2 times 3. So 2 times 2 times 3 is what gives us 12, and then we have a single x, and then we have 2 y's. So when we're talking about GCF, we're saying how much can we take out of each of these? In other words, what's the most of everything that they have in common? Well, I have, if we look over here, right, I actually have a 2 and a 2, and over here I have a 2 and a 2, right? So we know that we can take both of those out. On this side, we have an x, and on this side, we have an x. And then finally, we have a y here, but we have 2 y's over here, right? But the most we could take out of each of those is just a single y. So when we go to find our GCF, I know this is really a long explanation of this, but the idea is we're going to actually take out 4x, y from both of these terms. And then anything that's left that isn't shared by both of them is going to be what we put in our binomial here. So we're going to have, for the first term, we have 2x. And then for the second term, we have 3y. So 2x plus 3y. And now, if we want to check our work, all we have to do is the distributive property, right? So 4xy times 2x is going to give us 8x squared y, which is actually our original term. If we look back up here, you'll see 8x squared y right here. And for the second one, we're going to do 4xy times 3y. So plus 4 times 3 is 12. There's no x's over there, so x and then y squared. And if you look back up at the top, we have 12xy squared. So when we factor using the GCF, this would be our factored form using the GCF. Now, you don't have to do this every single time, right? You don't have to sit here and break it down. But the more that you understand exactly where these pieces are coming from, the more it'll kind of help you go from there. All right, so that's finding the GCF. Now we're going to move on to the next stage here. All right. So the next thing we're going to talk about is what we call difference of squares. Now, I'm going to do a problem with you guys, and then just to kind of, I'll go like both ways, just so you guys can kind of see what it looks like. But let's say I have the binomials x minus 5 times x plus 5. All right, so we're going to start from the other side. Normally, what you would do in this case is you would have your equation, and then you would kind of separate it into this. But I'm going to go backwards just to kind of show you. So if we FOIL this, right, we're going to have x squared, and then plus 5x, and then minus 5x, and then minus 25. So when we have these like terms here, and those are going to cancel out. So our final answer is going to be x squared minus 25. And the reason we call this a difference of squares is because, well, we have a difference, right? If we look here, we have our subtraction sign, and then we have x squared, and then 25 is actually just 5 squared, right? Which you'll notice that both of these originated as 5s. So, in other words, if we want to take this and make it more general, if we have a squared minus b squared, what this is going to equal is a plus b times the quantity a minus b. All right, so let's go ahead and do one real quick, and then I'll give you guys one to try over here. So let's give ourselves a little bit more space here. All right, so let's go ahead and try one. So the one we're going to try is 4y squared minus 64. And we are going to turn it into a set of binomials which we could FOIL, right? We don't have to do the FOILing now, but that's kind of just the way it would work. So, all right, first thing I'm noticing is I see 4y squared. Well, 4y squared can be broken down into, if we want to look at it this way, right? 2 squared is 4, and then y. So if we want to break this down like this, 2y squared is the same as 4 times y squared, right? Because the 2 squared would be 4, and then the y squared would be y squared. And then 64 is what? Just 8 squared, right? So we have 8 quantity squared. And now you'll notice that we have this, which we can call a, right? And we have this, which we can call b, and they're both squared, right? We have the square here and square here. So anywhere that we would see an a in our form, we put 2y, and anywhere we'd see a b, we would put our 8. So if we scroll down a little bit, we could rewrite this as 2y plus 8 and 2y minus 8. So all we did is we took this original form, the a squared minus b squared, we found what a had to be, and we found what b had to be, so that we can convert it into this form up here. So now, if you just want to FOIL this out just to kind of double check and see if you did it right, 2y times 2y would be 4y squared. 2y times negative 8 would be minus 16y. 2y plus 8 would be plus, or 2y times positive 8 is plus 16y. And then 8 times negative 8 is negative 64. And of course, just like always, these middle terms cancel out, and we get 4y squared minus 64. So it does work. So if you want to factor this piece right here, it's going to turn into this binomial down here, or the set of binomials using difference of squares. So if you want to try one on your own, we'll come back up here. Go ahead and try this one. We have all right. So go ahead and try this. Go ahead and try 8x squared minus 18. And I'll give you a hint. Take out a GCF before you actually do the difference of squares. It'll help you out. You'll see what I mean. All right. So let's move on to the next thing. Okay, next is going to be factoring trinomials. All right, factoring trinomials. So let's go ahead and start off with something pretty straightforward. These, we're going to start off with the first ones, are going to be when a equals 1, which are definitely the easier of the two. So if we have x squared plus 11x plus 30, we are trying to factor this into something that would look like this, right? Where we have two binomials, and really what we have to figure out is what multiplies to get 30 that adds to get 11. So if you want to list all the factors, you can, but I know that 6 times 5 is 30, and 6 plus 5 is 11. So really all I have to do is we're going to write our x's here. And because I said our factors were, what did we say, 6 and 5, right? So we know that this is going to be x plus 5 and x plus 6. And that's our final answer. right? And if you want to FOIL it back, right, you'll get 6 and 5, right? So you'll get x squared plus 5x plus 6x plus 30, right? And then the 5 and the 6 combined, and you get exactly what you started with. So those aren't too bad. Hopefully you just practice those a little bit, and then you'll get those. So if you want to try one, let's do x squared plus 2x minus 15. Okay? And so just try to find all the factors which multiply to get 15 that add together to equal 2. All right, perfect. So factoring trinomials where a equals 1 is pretty straightforward. But what happens if a doesn't equal 1? And this is where it gets a little bit more complicated, but it's not too bad. So if a doesn't equal 1, how do we do this? Well, let's take a look. So if we have 2x squared minus 5x minus 3, well, you'll notice that, first of all, this 2 here at the very front is kind of messing with everything. And there's not really anything that multiplies to get negative 3 that adds to get negative 5. So it wouldn't really work with our original method anyway. But what we can do is we can actually use a method. I've seen people use this little like tree idea, and it kind of works. And the idea is we want to know what multiplies to get our AC, right? Remember that this is like A, this part here is B, and this part here is C. So we want to know what multiplies to get AC, which in this case is negative 6. That also adds to get B. So we want to plus for B, which in this case is negative 5. So we want to know what are the factors of negative 6 that gives us negative 5. Well, we could list a bunch of factors if you want to, but I'll just kind of help you with this one. So we have negative 6, right? And negative 6 times 1 is negative 6. And negative 6 plus 1 is negative 5. So over here on the sides, I'm going to put negative 6 and plus 1. And these are going to be the pieces that we use. So these are kind of the important parts. This just helps us set everything up, okay? So now what we're going to do is we're going to take our middle term here, this negative 5x, and we're going to break it up into a negative 6x and a plus 1x. So essentially we're taking this negative 5 and we're splitting it, right? So we'll start off with 2x squared, and then the negative 5 is going to become negative 6x, and then plus 1x, and then just minus 3 at the end, right? And you realize that we're not actually changing this equation at all, right? Because negative 6 plus 1 is negative 5. We didn't actually change the value of anything. All we did was break this apart. So now what we can do is a concept that we're going to learn here in a second as well. But this is what's known as factoring by grouping. And the way factoring by grouping works is we take the first two parts here, and we take the second two parts here, and now we find the GCF of both and pull it out. So let's do that. So if we have 2x squared minus 6x, looks like I can take a 2 and I can take an x. So I'm going to pull a 2x out, and that's going to leave me with x minus 3. And then on this side, well, it looks like we already have x minus 3, and there's not really anything we can pull out. So the most we're going to be able to pull out is just like a positive 1, right? So you don't actually even have to write the plus sign. I was just kind of doing that for an example. But yeah, so we're going to have a 1 over here. And then what does that leave us with? Well, we didn't really take anything out, right? So x minus 3. And you'll notice the whole point of this is that these two factors here, x minus 3 and x minus 3, are the same. And if you think about what we do when we FOIL, we multiply two different factors by the second set of in the binomial, right? So in other words, if we have, like, let's just do like letters. So a minus b, let's make it plus. And then a plus c, right? Essentially what we're doing is we're going to get a squared plus ab plus ac, right? Plus bc at the end, right? And the idea is that this a is being distributed to both of these terms, and this b is being distributed to both these terms, right? So in other words, if both of these things are being distributed to the same thing, it's as if we're FOILing it. So we can rewrite this as 2x plus 1, right, both of these pieces, times x minus 3. And again, it's because we're multiplying both of these pieces by x minus 3 that we're allowed to combine these terms. And this here is our solution. This is the factored form. In fact, these are factors. If we wanted to set them equal to 0, we could find the zeros, right? Okay, so let's go ahead and give you guys one to try. So if you want to give this one a shot, try this one. Try 2. No, here. Not 2. Try 3x squared plus 5x minus 2. And if you want to give that a shot, go ahead. All right, we are going to continue with the final part of this here, where we are going to do factor by grouping. Okay. Now, factoring by grouping is nice when we have 4 terms. So let's go ahead and give you an example here. So let's do x cubed plus 2x squared minus 5x minus 10. All right. Now, first thing we have to do is check if we can even do factoring by grouping. And the way we do that is we look at the ratio of the coefficients of these terms. So here, this would just be a 1, right? So if we look at the ratio between the first 2 terms, what do we have? Well, we have 1 over 2, right? You see how this is a 1 and this one's a 2? And then the ratio of the last 2 terms are -5 and -10. So we want to know, are these equal, right? Well, -5 over -10 is just 1/2. So this checks out. We can use factoring by grouping because the ratio of our terms right here and here are the same as the first 2 terms. So now we can factor by grouping, which is kind of what we did before, right? We're going to take this, and we're going to take this, and we're going to kind of break them down by separating them. So we're going to take this side, and we're going to take out the GCF. So if I have an x cubed plus 2x squared, the most I can take out of each of those is an x squared. So I'm going to pull out the x squared, and that's going to leave me with an x plus 2. All right, now over here, I have a -5x and a -10. Looks like I can take a -5 out of each of those. So I'll do that, and I'll get an x plus 2. And wouldn't you know, we have x plus 2's for both of them here. So we can rewrite this as x squared minus 5 times the quantity x plus 2. And that's our final answer by grouping. So go ahead and try this one here. Let's see. So we have 4x cubed minus 8x squared. Wasn't my best 8. That's all right. Plus 3x minus 6. All right. So yeah, go ahead and try this one. First of all, check the ratios, make sure they're the same, and then go ahead and factor by grouping. All right. So bonus puzzle here. This one's not a. This one you will use sometimes. I know we've kind of touched on it in the past as well, but I just want to make sure that we're good here. We are going to factor by completing the square. Okay. So let's try this. So factor by completing the square. We have x squared plus 6x plus 7. Now, the first thing you should always try in these problems is just to see if there's anything that works as far as, like, we notice that our a is 1, right? We don't have anything in front of the x squared over here. So first we should try to see if we can just factor this the old way, right? Where basically we have a term here and a term here, right? And we really want to know, like, what multiplies to get 7, that adds to get 6. The only things that multiply to get 7 are 1 and 7, and there's no way to manipulate like positives and negatives because everything's positive. So Yeah, there's not really a way to do it. So what we have to do is we're going to try to find a way to make it so that we can actually have the same number on both sides here. And the way we're going to do that is by using this little equation here, b over 2 squared. And essentially what this is we're going to plug our b into here, right? So we have 6. We're going to plug in our 6 right here, and we're going to get 6 over 2 squared. Now 6 over 2 is an important number. Keep the 3 in your mind, right? But 3 squared is 9. So 9 is going to be the number that we are going to have to use as well. So keep the 3, but also remember this 9 because we're going to use both of them. Now the idea is if we can somehow turn this 7 into a 9, then what we can do is we can set this up by completing the square. So what I'm going to do is I'm going to rewrite this as x squared plus 6x. Now, in order to turn this 7 into a 9, we have to add 2. So I'm going to put plus 9, but then I'm also going to put minus 2. Okay? Because I added 2, I have to subtract 2 in order to keep this all equal. Right? I can't just add numbers for no reason, right? So if I add 2, I also have to subtract 2. Now what's awesome is this part here, if I just like put a box around this part here can actually go into a form that looks like this, right? And that was kind of the whole point of why we did this concept over here, right? We did this whole thing, all these shenanigans, so that we could get this 9 to be a number that would work, okay? So that's what this formula does. It takes this 9 and it creates this. And what? This is actually really cool how this works out. Because now, what numbers multiply to get 9 that add to equal 6? Well, it's 3 and 3, right? It's the same number. So now if we do this, we have x plus 3, right? And then x plus 3. You notice it's the same number twice. And the reason why we call this completing the square is because x plus 3 times x plus 3 is actually just x plus 3 squared, right? And then minus 2. So this is one way. This answer would be correct. This answer would be correct. It just depends on what you're trying to do. This second answer actually would help us solve equations because now we can set this equal to 0 and we can take the square root of both sides and do all the stuff we used to do in Unit 2. So if you want to give this one a shot, let's give you a problem here. X squared minus 4x plus 12. So go ahead and give those a shot. If you have any questions with them, just let me know. And I will see you guys in the next video. Good luck with your factoring.